Hello guys, how are you today? I hope everyone's doing well, and I really apologize for posting late yesterday. I have my IGs still, so please keep that in mind. So if I don't post early or if I post late, you just know that I'm probably studying for my IGs, okay? So, which of the following particle diagrams best represents the substances present when 6 molecules of H2 react with 2 molecules of oxygen gas are ignited producing water molecules? So they said what? They said H2, okay, will react with O2 to form what? To form water molecules. Water molecules is H2O. How do we find the limiting reactant? So in this case, in order for us to find the limiting reactant, we first need to take the balanced equation of the most basic one. The most basic one in whole numbers, its balanced structure is gonna be 2H2 plus O2 will give us 2H2O. So always take the simplest, based on whole numbers, structure of the equation, okay? Now, you write what they gave you. They gave you 6H2 will react with what? Will react with 2O2 to form water, okay? Now, as you can see, you're gonna take the number of moles and you're gonna divide it by their coefficient. So the number of moles here is 6 divided by the coefficient, which is 2. The number of moles here is 2 divided by its coefficient, which is 1. 6 divided by 2 is 3. 2 divided by 1 is 2. Now, which is the smaller value? 2. In this case, that means what? O2 is our limiting reagent. If O2 is our limiting reagent, then that means what? Then that means we will have to balance the full equation based on O2. Balancing the full equation based on O2, you're going to get 4H2 plus 2O2 is going to give us what? Is going to give us 4H2O. So now what we're going to do is we're going to see what is remaining. So first of all, as you can see over here, the 2O2 is fully consumed. So the 2O2 is fully consumed, meaning that in the products, we're not going to be able to see the 2O2. However, 6H2 became to 4H2. So 4H2 of the 6H2 was used. That means 2H2 was left behind. That means in the product, you're going to see 2H2, 2 hydrogen molecules. And then finally, you have in the product here 4H2O. So you're supposed to see what? 4 molecules of H2O and 2 molecules of H2. Then you look at the graph, you see which one is the corresponding graph. In this case, it's going to be this. Here they give you what? They told you that the small is hydrogen, the big is oxygen. So this is 4H2 plus 2H2. We move on to question number 2. In question number 2, it says a mass of 17.6 gram of a hydrocarbon CXHY was burned in the presence of excess oxygen gas, O2 in a closed chamber. The mass of carbon dioxide, CO2, collected was 52.8 grams. And in the blank, by writing the mass percent of carbon in this hydrocarbon. Very simple. This requires a few steps. The first step is we need to read clearly and we need to see which one is the limiting reagent. They said this was burnt in the presence of excess oxygen. If this is the case, that means all of the carbon and all of the hydrogen is used up. What does that mean? Also, that means the carbon in the reactants is equal to the carbon of the products. So if you find the mass of carbon in the products, it's going to be the same as the mass of carbon in the reactants. So very simply, they told you that carbon dioxide, which is the product, it collected 52.8 grams. So that means we're going to find the number of moles of CO2. It's going to be the mass, which is 58.2, divided by the molar mass, which is 12 plus 16 times 2. You will get 1.2 moles. Okay, now that you have the number of moles, you will be able to find the mass of carbon. So the mass of carbon is equal to the number of moles multiplied by the molar mass, which is what? Which is 14.4 grams. Now they want what? They want the mass percent of carbon in this hydrocarbon. So you're going to take the mass of carbon, which is 14.4. And you're going to divide it by what? You're going to divide it by the mass of the hydrocarbon, which is 17.6, and multiply it by 100. So 14.4 over 17.6 times 100, you're going to get 81.818, etc. So this is in percentage, but they needed to 3 significant figures. So you'll take 1, 2, 3. It will be 81.8%. Very simply, the answer is 81.8%. We move on to question number 3. The mass of various iron fillings sampled was measured using different scales. Write the number of significant figures. Okay, this is a very easy question. So, the number of significant figures in each one of them. This has 1, 2, 3. 3 significant figures. Why? Because the 0 after the decimal place, and if it's after a whole number, of course, then we will say what? We will say it is a significant figure. Here you have 2 zeros. They are trailing zeros, but they are followed by a decimal place. If they are followed by a decimal place, then definitely they are significant figures. So this is gonna be 4 significant figures. Here you have 4, 3, 0. There's no decimal place, so that means you will only consider 4 and 3 as significant figures. So you have 2. And then finally over here, before a significant number, you don't take it. But if it's after a decimal place, okay, or there's a decimal place after, and there is zeros after the significant number, then you will say what? Then you will say it's a significant figure. So here it is 3. So 3, 4, 2, 3. Okay, so we move on now to question number 4. In question number 4, it says, given below the mass spectrum of a sample of unknown element, choose the number of isotopes it have. You just look at the percentage. So here you have 1, 2, so it means it has 2 isotopes. Now, the average atomic mass. How do we find the average atomic mass? Very simply, the average atomic mass, or average atomic mass. I'm just gonna, I forgot how to write it. I'm just gonna write the mass, the average atomic mass. It is equal to what? It is equal to, actually no need for this. It is equal to the mass multiplied by its abundance, so 35 times 75%, plus the other mass, 37, multiplied by its abundance. What you notice is that these two mass will give us a value of 100, these two percentage will give us a value of 100 if you will add them. So put it on your calculator and you will get an approximate value of 35.5. So that means the average atomic mass is 35.5. Using the mass spectrum and the periodic table, give the chemical formula of the element. Just look on the periodic table, see which one has an atomic mass of 35.5. It is chlorine, Cn. We move on to question number 5. Oh, nice question. A rigid tank was filled with 20.7 grams of oxygen gas O2 and firmly closed. Using the data in the table below, fill in the blank by using the number of moles of oxygen gas inside the tank and the pressure it exerts. Give your answer to correct number of significant figures. The number of moles of oxygen O2 inside the tank. How do we find the number of moles? It's very simply, so N of O2 is the mass, which is 20.7, over the molar mass of O2. Pay attention, so it's 2 oxygen, so it's 16 times 2. So it's going to be 0.647. So very simply, it is going to be 0.647. We move on to part B. They said the pressure exerted by oxygen gas O2 inside the tank. How to find the pressure exerted by oxygen gas inside the tank? We very simply need to apply the equation PV equals nRT. So the pressure, which is what we need to find, volume, we have it, number of moles, we have it, R, we have it, and T, we have it. So pressure is going to be equal to what? nRT over the volume. The pressure, we need to find it. It's equal to the number of moles, which we found previously to be 0.647, times R, which is 0.082, times what? Times the temperature, but the temperature always has to be in Kelvin. So plus 273, so it's going to be times 27 plus 273, over what? Over the capacity, which is the volume. So you will put it all on your calculator and you will get an approximate value of 1.2 atmospheres. Okay, so it's going to be 1.20. Pay attention, because the correct number of significant figures, you will look at the values up. It is the least amount of significant figures. And what is the least amount of significant figures? It's 1, 3. So this is 3, this is 3, this is 3. So it's definitely going to be 3. This is how you choose the correct number of significant figures. We move on to question number 6. Okay, Consider the reaction N2 plus 3H2 gives us 2NH3. A sample containing 9 grams of H2 is reacted with 2 moles of N2 to produce 20.4 grams of NH3. Calculate the percentage yield of the reaction. Again, 9 grams of H2, that means how many moles will it be? It's going to be 9 over 2, so mass over molar mass to be 4.5 moles. So 4.5 moles of H2 reacts with 2 moles of N2 to produce what? To produce 20.4 grams of NH3. Now we will see how many grams of NH3 will be produced. So this over here is what? This is our actual mass. And what we find over here, this will be our theoretical mass. Okay, but here's the thing. Percentage yield, this is what? It is the actual over the theoretical times 100. That's how you get what? The percentage yield, PY. Okay? So let us find the theoretical mass together. To do that, we need to find the limiting reactant. So in order to do that, we will divide by their coefficient. So this is the number of moles, 4.5. Divided by the coefficient over here, which is 3, you will get 1.5. You will divide this number of moles by the coefficient over here, which is 1. So it's going to be 2 over 1, which is 2. Which one is smaller? This one is smaller. That means H2 is our limiting reactant. That means the whole reaction will be based on H2. So if 3 moles of H2 became 4.5 moles of H2, how much will 2 moles of NH3 become? It will become very simply times 1.5. It will be 3 moles of NH3. So let's find the theoretical mass of 3 NH3. It's going to be 3 times 14 plus 3, which is 51. So now the actual, which is 20.4, over the theoretical, which is 51, times 100. Put it on your calculator, and you're supposed to get an answer of 40%. So very simply, our answer is 40. I wanted 2 significant figures, so don't forget to put the full stop. 40%. We move on to question number 7. A sample of hydrated TuSO4 with a mass of 25 grams was heated until all the water was removed, and then it became 16 grams. Okay, so how much of the mass was water? It's 25 minus 16, which is 9 grams. So this is what the mass of water. Now that we have the mass of water, we need to find the number of moles of water. So the number of moles of water, it's going to be the mass over the molar mass. It's going to be then 1 over 2, or 0.5 moles. Now, let us also find the number of moles of CuSO4. To find the number of moles of CuSO4, it is what? It is 16 grams, the remaining mass, over the molar mass, 160, which is then 0.1 moles. Now, pay attention. 0.1 became 1. How much will 0.5 become? It will very simply become 5. So, x is equal to 5. We move on to question number 8. This question may seem what? It may seem complicated, but it's very, very, very easy. Okay, 0.66 grams of hydrocarbon was burned in excess oxygen. That means all of the hydrogen and all of the carbon was used. 1.08 grams of H2O was produced. That means the mass of hydrogen before is equal to the mass of hydrogen after. Deduce the empirical formula of the compound. So, based on this rule, we need to find only the mass of hydrogen here in order to find the mass of hydrogen there. So how does that work? First, you have the mass, 1.08, divided by the molar mass of H2O, which is 18. Okay, you're going to get the number of moles, which is 0.06 moles. Next thing we're going to do is have the mass of hydrogen. Mass of hydrogen, we have 2 hydrogens over here, so it's going to be 0.06 times the molar mass, here in this case it is 2, it's going to be 0.12 grams. Now you have what? You have the mass of hydrogen after, which is the same as what? It's the same as the mass of hydrogen before. Okay, so now in order to find the mass of carbon, it's gonna be the total mass, which is 0.66, minus the mass of hydrogen, which is 0.12. Put it on your calculator, and you're supposed to get an answer of 0.54. So now we have 0.54 and 0.12. We're going to divide them by their molar masses. So divided by 12 divided by 1. This is going to be 0.045 and this is going to be 0.12. Now we're going to divide by the smallest ratio. In this case, it's 0.045. And you're going to get your answer to be what? You're going to get, this was for carbon and this was for hydrogen over here. So the carbon is going to be 1 and hydrogen is going to be 8/3, but we cannot leave it as a fraction, so you can multiply both ends by 3. So multiply here by 3 and here by 3. You will get that carbon has 3 atoms and hydrogen has 8 atoms. So it is what? It is C3H8. We move on to question number 9. Okay, this question over here. A mixture of at 25 degrees Celsius contains 3 mole of CH4 and 6 mole of O2 under a pressure of 0.75 atmospheres. The gases were combusted according to the following reaction. Calculate the pressure in the container after the reaction had gone to completion and temperature returned to 25 degrees Celsius. So for this one, you will need to apply the equation what? PV equals nRT, but in another way. You have to apply that. First, you will make it a ratio, okay? So it's gonna be N1R1T1 over P1V1. This is for the first, the reactants, is equal to N2R2T2, which is the products, over P2V2. What do we know here? We know that it was 25 degrees initially, 25 degrees finally. That means the temperature is the same. We know that the volume is the same. R is always the same no matter the case. So we are left with N1 over P1 is equal to N2 over P2. So let us look at the ratio of the moles. Here, it's 1 mole plus 2 moles. This is 3 moles. Here, it's 1 mole plus 2 moles. This is also 3 moles. So the ratio is 3:3, which is 1. If you ever get a ratio that is 1, then directly you know what? You know that P1 is equal to P2. In this case, 0.75 atmospheres is going to be the same. So 0.75 atmospheres. Move on to question number 10. For copper, okay, A is 64, Z is 29. How many protons, neutrons, and electrons do copper atom have? So copper is Cu. It has what? It has a molar mass of 64, or like a mass of 64, and an atomic number of 29. That means it has the number of protons to be 29. Because it's an atom, it does not have a charge, the number of electrons is going to be the same. And the number of neutrons is going to be what? It's going to be the mass number 64 minus the number of protons 29, which will give us an answer of 35. So protons is 29, neutrons is 35, and electrons is 29. We move on to question number 11. Student's temperature was measured to be 39.5 degrees. How much is the student's absolute temperature? Absolute temperature means in Kelvin. So you have degrees Celsius. You want to change to Kelvin. You have to add 273. So you put it on your calculator and you will get an answer of 312.5 Kelvin. So 0.5. We move on to question number 12. Okay, so this question over here. Naturally occurring lithium is composed of 2 isotopes, have an average atomic mass of 6.9. Calculate the percentage abundance. Let's take the percentage abundance as X. Then we will know what? That the average atomic mass, which is 6.9, is equal to 6 multiplied by the abundance, so 6 times X percent, plus 7 times what? Remember that the percentages, they're going to be equal to 100 if you add them. 7 times 100 minus X percent. Okay, you can easily change the percentage to over 100. So 6.9 is equal to 6x over 100 plus 700 minus 7x over 100. So now you can put this as one common denominator, which is 100, and you bring it to the other side to multiply. In that case, you're going to get 690 is equal to what? Is equal to minus x plus 700. Move this to the other side. Minus 10 is equal to minus x. So the abundance for the lithium-6, it's going to be what? It's going to be 10%. And because, remember, you add them, they are going to be 100. If this is 10%, then for sure this is going to be 90%. Move on to question number 13. Here you should remember the formula. So when they tell you, okay, wait, we're dealing with acids. We're naming the acids of the given formulae. We know that these are the anions. So very simply, the formula is going to be what? H, because remember, always acids have hydrogen in them. So it's going to be H and then the anion. So HClO4 for perchloric acid, then HClO3, then HClO2 and then HClO. Okay, now how do we name the anion? Very simply, how do we name the anion? We have 4 different anions over here. These are these are oxyanions. So how do we name if we have 4 different anions? We will take the one with the most oxygen, the one with the least oxygen. We're gonna keep them aside for last, and we will deal with the ones in the middle. The ones in the middle, the one that is closest to the least, it will take what? It will take the ending of "ite." So it's gonna be "chlor," which is the root of the name, and then "ite." However, the one that is closest to the one with the most oxygen will take the suffix "ate." So it's gonna be "chlor," so the root "chlor," and then "ate." So chlorite if it's closer to less oxygen, chlorate if it's closer to more oxygen. Now for the one with the most oxygen, it's gonna get what? It's gonna get a prefix of "per." You're gonna put then its root "chlor," and it will take the ending of "ate." So perchlorate. However, for the one with least oxygen, it's gonna take a prefix of "hypo," then the root "chlor," and then it will take the ending "ite." So perchlorate, chlorate, chlorite, and hypochlorite. So perchlorate, chlorate, chlorite, and hypochlorite. We move on to question number 14 here. This is very easy. You should know how to name them by now. This is nitrogen trichloride. Okay, what is the formula of oxygen difluoride? Oxygen is O, difluoride means you have 2 fluorine, OF2. We move on to question number 15. What do we call a negatively charged ion? It is an anion, very simply. Question number 16. Periods are the rows, not rows. Groups are the columns. Question number 17. Okay, representation and the form. When you see like something like this that's big and takes up space, you should know that it's a space filler. When you see something that looks like a bunch of balls and sticks, you will know that it's a ball and stick model. When you see this over here, okay, you will know that it's a structural formula because it's describing its structure. And when you see just the general formula, you will know it's what the molecular formula. We move on to question number 18. Okay, so very simply, if they share bonds, then they are known as what? They are known as covalent bonds. However, if they lose and gain, if they share electrons, they are known as covalent bonds. But if they lose and gain electrons, then they are known as ionic bonds. Positively charged ion is a cation, and a negatively charged ion is an anion. Number 19. Okay, you have to distinguish between mixture and pure substance. Bottled water is a mixture. Ammonia is a pure substance. Seawater is a mixture. Air is a mixture. Methane, however, is a pure substance. Now, petroleum, this may confuse you, but it's a mixture. How do we know? If you remember what we took last term, it was you would like separate petroleum using the difference in boiling points using fractional distillation. So that means it's a mixture if it can be separated. Move on to question number 20. Okay. Chemical change means you cannot go back. So if you burn wood, can you turn it back to how it was originally? No. But evaporating water, you can. So it's a physical change. If you grill fish, can you turn it back to how it was originally? No. So it's a chemical change. However, if you melt iron, you can. Number 21. A compound has a bunch of elements, whereas an element is just an element. So this is a compound, this is an element, this is a compound, and this is an element. So question number 22. This looks hard, but it's not hard at all. It's very, very easy. So look what we're going to do. As you can see, all the masses add up together to be what? To be 100%. So you can take the total mass to be 100%, and the percentages are just mass. So it will be 3.04 grams, then 14.78 grams, and then 12.18 grams. What we're going to do over here is we're going to divide by their molar mass. So this is going to be divided by 12. This is going to be divided by 1, and this is going to be divided by 14, of course, corresponding to which element they are. Okay, so for this one, 73.04 divided by 12, it will give us a value of 6.09 approximately. 14.78, my bad. It's gonna be 14.78. And then this over here is gonna be what? 0.87. Now, as you can see, the ratios, they're all different. They're not even whole numbers. So in order to make them whole numbers, you will divide by the smallest possible ratio. When you divide by the smallest possible ratio, what will you get? You will get, for this one over here, you will get 7. So you will get that this is 7 atoms. You will get that this is approximately 17 atoms, and you will get that this is 1 atom. That means if C is X, that means X is 7. If H is Y, that means Y is 17. And if N is Z, that means Z is 1. So it's 7, 17, and 1. We move on to question number 23. Okay, this I think you guys should have memorized it by now. So, all metals have a silvery luster. If they can be drawn in 2 wires, then you say they are ductile. If they can be hammered, then you say they are malleable. Metals are heat and electrical conductors. We move on to question number 24. Okay, genuinely this question is very silly. Okay? Not silly, it's very easy. You can get 3 marks. So how do you find the percentage for each of them? You just find the total mass of the compound. So in this case, it's going to be 46 grams. This is the total mass. And then you're going to take the mass of each element in the compound. So carbon, it's going to be what? Carbon, the total mass in this case is 12 times 2. So it's going to be what? 12 times 2 over 46 times 100 will give us 52%. Okay? Then, for hydrogen, it has 6 grams, so it's going to be 6 over 46 times 100. So it's going to be 13%. For oxygen, however, it is 16 grams. So it's going to be then 16 over 46 times 100. So if you calculate its percentage, it's approximately 35%. So in order, it is 52%, 13%, and 35%. Let's submit, and hopefully we don't have any mistakes. And perfect, thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.